This video is going to cover binomial distributions. So we've been talking about discrete random variables. So what a discrete random variable does is it maps the outcome from some random experiment to a number. The binomial distribution is a special example of a discrete random variable. So whenever you have a series of yes/no random experiments, and you count the number of yeses, you got a binomial. So these are extremely common. And if you think about click, not click, I expose 100 people to a banner ad, and I'm going to count the clicks. Well, I have a bunch of yes/nos, and I'm counting the number of yeses, so that makes it a binomial random variable. If I ask people, I do a survey and I ask them, do you recall yes or no seeing some ad? If I count the yeses, I've got a binomial random variable. If I send out 100 direct mail pieces and I count the number of responses, notice people either respond or not respond, I've got a binomial. So these binomials come up all the time in marketing, and that's why we study this distribution separately. Let's develop the binomial in a little more systematic way. So first off, let's talk about a Bernoulli trial. So Bernoulli trial is any random experiment where you have only two outcomes. Now we generically label these things success and failure. I often lapse into yes and no. So whatever you want to call the two outcomes, you got two of them. All right, so flipping a coin is of course the classic example. Respond, not respond, click, not click, male, female. All of those would be Bernoulli trials. The other thing is that we're going to use the Greek letter pi to indicate the probability of a success. So that's universally in this course, pi means the chance of a success from some Bernoulli trial. So if it's a coin flip, that pi is usually 0.5 as long as it's a fair coin. Now let's move on to binomials. So what's the difference between a Bernoulli trial and a binomial? Well, a binomial is where you do n Bernoulli trials and they're all independent of one another. And these Bernoulli trials are also identical to each other in that they all have the same probability of success. So if I do n yes/no experiments and I count the number of yeses, the number of yeses or successes is xb, and that's a binomial random variable. So whenever you do something n times, you count the number of yeses, you got a binomial. Let's do a little example now. Let's say that I call up, well, first off, let's assume that we know that recall for some ad is really good. So it's 0.6. So if you expose somebody to this ad, they're going to remember it with probability 0.6. Maybe this is some really good Super Bowl ad. Now let's say we call up a random sample of 4 people who watched the television show on which this ad was aired, and we ask them, do you recall seeing it, yes or no? Question, what's the probability that exactly 3 of the 4 people we call recalling seeing the ad, indicating yes, they saw it? Alright, well, let's think about this. There are 4 possible ways that I can get 3 yeses out of 4 tries. So let me enumerate those for you here. This first row means that the first person says yes, the first person to call, the second person says yes, the third person says yes, and the fourth person says no. Another possibility is that the first 2 people say yes, the third person says no, and the fourth says yes. So the third way is that the second person says no, and the last way is that the first person says no. So I claim there's only 4 ways that I can get 3 yeses out of 4 tries. Now let's evaluate the probabilities of each of these outcomes. So let's start with the first. Recall that we've got independence. So with independence, we can multiply the probabilities. So if you're not convinced of that, let's go over to the sketch pad for a second. And remember that if yes 1 and yes 2 are independent, then the probability that you say yes to question 1 and that you say yes to question 2 is just equal to the product of the two. So that's the product of the probability of saying yes to question 1 and the chance that you say yes to question 2. So that really simplifies our life, this independence, because we can just multiply across. Alright, so what's the chance that you get yes, 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 no? Well, it's going to be 0.6 times 0.6 times 0.6 times the chance of a no, so the complement of a yes, 0.4. And that probability works out to be this. So let me emphasize what that probability tells us. This is the chance that if we call 4 people up, the first 3 say yes and the 4th says no. Let's evaluate the next probability. So what's the chance of yes, yes, no, yes? Well, 0.6 times 0.6 times 0.4 times 0.6. And because multiplication is commutative, it doesn't matter what order we do these in, you get the exact same number, but this is a distinct event. So this first row is yes, 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 no. The second event is the chance that you get yes, yes, no, yes. Likewise for the other 2 events. Now, we can add these up. The reason that we can add these up is that they're mutually exclusive. We're just using the OR theorem, and we're adding up the probabilities. Now, that probability then represents the chance that we get 3 yeses out of 4 tries and answers the question. However, I hope that you find that what we just did was pretty difficult, and therefore we'd like to find an easier way. So let's do that. Let's get a little bit clever about this. What did we do? Well, there are 4 ways of getting 3 yeses out of 4 tries. And then if you look at the formulas up here, each one of them involves 3 copies of 0.6 because we want 3 yeses. And they all involve 1 copy of 0.4 since we want 1 no. So that probability, 0.3456, is just 4, number of ways, times the probability of a yes raised to the number of yeses that you want, times the probability of a no raised to the number of no's that you want. So that's the general formula if we write it out. Now, let's do this for a few other possibilities. The problem I just took you through asked for the probability of 3 yeses out of 4 tries, but that's not the only thing that could happen. Another thing that could happen is 4 yeses out of 4 tries. I call up 4 people, they all say yes. So what's the chance of getting 4 yeses out of 4 tries? Well, there's only one way that you can get 4 yeses out of 4 tries. And what is that? Well, I call them up, it's yes, 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 yes. And that's the only way you can get 4 yeses. So therefore, the number of ways is 1 times the probability of a yes, 0.6, raised to the number of yeses, well, you want 4 yeses, times the probability of a no raised to the number of no's, well, you want 0 no's. So this is 1. Right? So the chance that you get 4 yeses is 0.1296. That's not the only thing that could happen. What's the chance that we get no yeses? Well, there's one way to get no yeses, that is no, 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 no. You want 0 yeses, you want 4 no's, here's the chance of 4 no's. How can we get 1 yes? Well, either the first person says yes, the second person says yes, the third person says yes, or the fourth person says yes. So there's 4 ways that you can get 1 yes. You want 0.6 to the 1, 0.4 to the third. So the chance that you get 1 yes out of 4 tries is 15.36. The one that's going to be slightly more difficult is 2 yeses out of 4 tries. Turns out there's 6 ways, and here's the probability. Well, now if you think about it, we have just stumbled on a random variable, right? So we've derived the probability distribution. These are theoretical probabilities. We started with a small set of assumptions and derived the entire probability distribution for this binomial. Now, since this is a discrete random variable, remember with Ed's simple table, we want to add up the probabilities, make sure they sum to 1. If you add these up, you will find that they do indeed equal 1. Then if we want to find the means, well, the mean we multiply across. So 0 times 0.0256 is 0, and so forth. The mean of this is 2.4. Now let's just think about what that means. on the average, we would expectation 2.4 yeses if we call up 4 people and ask them if they recall seeing this ad. We can graph this, this distribution, and I've done that below. Here's what it looks like. The mean is at 2.4, so if I stick a wedge about here, I hope you'll agree that that thing looks like it would be in balance at about 2.4. Finally, we want to find the variance. So the variance, we find the squared deviations, multiply by the probability, and you get 0.96 as the variance. Take the square root of that, you get the standard deviation, which is 0.98. All right, now a question that people always ask is, where do these number of ways come from? Turns out there's a formula for it. I don't think it's terribly important that you know this formula, because you're going to be using Excel to find these probabilities, but it's worth us spending a few minutes going over this formula. So here is that formula. It's called the combination formula. This is pronounced n choose x, and it gives us the number of ways that you can get x yeses out of n tries. The way you work this formula is it's n factorial divided by the number of yeses factorial, so x factorial, times the number of no's factorial, so n minus x factorial. Now, you may not remember factorials from your math classes. That exclamation point means that you multiply all the numbers before it. So 3 factorial is 1 times 2 times 3. 4 factorial would be 1 times 2 times 3 times 4. By definition, 0 factorial is 1. So let's go check our work on the problem that we did. The first problem was, how many ways could I get 3 yeses out of 4 tries? We listed them all out. So it should be 4 factorial all over 3 factorial, the number of yeses, times 1 factorial, 4 minus 3 is 1, which is the number of no's. So if we work this out, sure enough we get 4, which is exactly what we got. Now let's go do another example on this. The other example is that I claimed there were 6 ways to get 2 yeses out of 4 tries. Let's go over to the sketch pad for a second and just confirm that. So how could we possibly get 2 yeses out of 4 tries? Well, it could be yes, yes, no, no. Notice we have 2 yeses. Or it could be yes, no, yes, no. Or it could be yes, no, no, yes. All right, then we could also start out with a no, and we could have yes, no, yes. Or we could have no, yes, yes, no. Or we could have no, no, yes, yes. And I think those are the only 6 ways that we can get 2 yeses out of 4 tries. Now let's just confirm that with the choose formula. So the choose formula is going to be something like this. 4 choose 2, which is equal to 4 factorial divided by 2 factorial times 4 minus 2 factorial. All right, so this is going to be 4 times 3 times 2 times 1 divided by 2 times 1 times, okay, what's 4 minus 2? 4 minus 2 is 2. So that's 2. So times 2 times 1. It's a 1. So that crosses out with that. The 2 crosses out with the 4, and we're left with 2 upstairs. And so 2 times 3 is 6, and sure enough, the formula works. So moving on,